Hi, I'm Kalav Litaru, and today I'm going to talk about how we use the cloud to understand television news. The goal of the Open Data GDELT Project is really this idea to use massive computing power to understand the world around us, cataloging in real time the events and narratives that drive society every day. Historically, only textual news was really understandable through machines. Today, through AI advances, we can process all modalities. And today I'm going to talk specifically about how we're processing video using the GCP Video API and also the Natural Language API to understand the captioning there. So in collaboration with the Internet Archive's Television News Archive, we have something called the TV Explorer. So this is the Television Explorer is an open tool that allows journalists and researchers to understand the coverage patterns of television news. Historically, we've used keyword search of closed captioning for this. So in other words, we take the closed captioning of every television broadcast and we index it as traditional text. So you can go in, you can type in your keyword or your key phrase, and it's a traditional keyword search of a large textual corpus. Every word's associated with a video timestamp, and so we can do these sort of real-time timelines and so on. Now, a lot of television news, not all television news is captioned. So, that means that we need to be able to use machines then to generate captions for those that don't have them. Now, traditionally, we view human captioning as the gold standard that machines strive to match. But in reality, television news is captioned by a live human being. Really, when you watch a television news broadcast, there's a live human being sitting at home, frantically typing away what they hear in real time. That's why closed captioning is delayed by a few seconds. But that also means that this is not the same as, when you watch a Hollywood movie that's been captioned, that's where oftentimes you've got multiple transcriptionists, they're all typing in, it's reconciled, basically they have the time to do it right. For television news, it's in real time. It's as they're seeing it. So it turns out that humans are actually not nearly as good as we think that they are. And they oftentimes skip a lot. So honorifics, titles. So if it says, this is so-and-so, the US ambassador to Estonia, who was previously the ambassador to such and such, all that's missing. It'll just say, this is so-and-so, period. Automatic speech recognition, so Google speech-to-text automatic speech recognition. Actually, so we've done a lot of comparisons between that and the human captioning, and it turns out the machine's actually as good as the human, and actually exceeds in many cases due to simply the fact that it's actually able to capture a lot that the human skips over. And just as oftentimes names, the machine might not know how to spell a particular human's name, again, the human transcriptions oftentimes are given ahead of time. Here's the different names. Same thing for the machine. If you have a list of the names that will appear in a broadcast, you can hand those to it so it knows how to spell those correctly. And so again, that's not to say that there's not error in that. There certainly is error, but to say that it actually matches what we get from humans from that. And so again, ASR is actually, today has reached a point where we can actually use it for live captioning of television news. Now, what we do with this, so what do we do with this? How do we actually then analyze these broadcasts? So once you have that text, whether it's machine-generated ASR or human-type captioning, we have a transcript of the broadcast now, so we can do traditional keyword search from that, but we can do really interesting things. So embedding, so you've probably all heard of embeddings before. We use something called the Universal Sentence Encoder v4. It's a tool that Google has released. They've actually released that model, the TensorFlow model. We use that. We generate embeddings over every single sentence in each of the broadcasts. So that lets you do really interesting things. So for example, we can take this fact check here. So this is a paragraph, a fact check, and we want to see how often is this particular claim appearing on television news. So traditionally, you take that as a human being, you come up with a set of keywords to use. But with embeddings, we don't have to. We simply take this, compute the embedding of it, and then perform something called approximate nearest neighbor, which basically goes through and simply takes every one of those sentence level embeddings and just looks to see which ones are the most similar. So in other words, we start off with a fact check, a one paragraph fact check, and we ask it for find me all of the sentences spoken in the closed captioning that are most similar to this. And here we have a ranking. And you can see here's one that refers to a nanochip, but the embedding is good enough to recognize that a nanochip in this context is probably the same as a microchip. So again, semantic search over television news without worrying about, again, trying to come up with keywords. You literally start off with a paragraph of text and you can just semantically search television news. We can do a step further, though. We can take those embeddings, put them in something called TensorFlow Projector, get another open Google tool, and we can visually cluster them. So we can take all those sentences and map out the narrative landscape of a broadcast. Now, this particular example I have here, this is actually based on online news coverage, but the same applies in television news. And because these embeddings are universal, we can actually take embeddings over television news, take embeddings over online news, and actually cluster those together and actually understand the narrative landscape of a particular topic. This is actually an example for COVID-19 vaccines. This was done with online news coverage, but we basically start off, said, find me all the articles mentioning COVID-19 vaccines in a given day and generate a narrative map of those. Now, again, then we can go a step further. We can take that text, run it through the Google's natural language API, which extracts out all the entities present in each article, and have it extract out all the names it found in a given broadcast. And then we can look at the co-occurrences. So which names occur with what names, and make a co-occurrence graph. This is actually visualizing Gephi here. We just took the entities, looked at which ones occur with which ones, and we can generate these maps essentially of their connections. And now what's really interesting is it performs co-ref. So the NLP API performs co-ref. So in a broadcast, oftentimes you'll see something where a news anchor will say, Senator Smith, tell us about such and such. Senator, what do you think about this? Senator, what do you think about this? So they just keep referring to the person as Senator. With the NLP API, it's able to perform co-ref and recognize that each of those subsequent references to Senator refers to Senator Smith, and so connect all that together. So it becomes very powerful for this kind of stream of consciousness that you see in television broadcasts. Now, the NLP API also performs dependency parses. So we can then take a sentence. We can actually do Q&A. So you can say, has Donald Trump met Al Gore? Entity extraction sees Donald Trump, Al Gore, sees that meet is the verb here. And then we can go over and say, find me references where those two entities appear with meet. And so again, we can then find, yes, the two have met. So again, Q&A based on that, taking that original sort of conversion, the text, and then using the NLP API to extract out entities and their connections, and then perform things like Q&A here. Even more powerfully, though, we can take the co-occurrences of those. So we, again, remember, we've extracted all these entities, so we can look at how often they occur with each other. We can do that and generate visualizations. But there's another tool called the Inference API. So this is another GCP API called the Inference API. We can take all these entities from the NLP API, feed them into the Inference API, and then we can do all kinds of things. We can say, take Robert Mueller here, find all the persons that are mentioned with him more often than they're mentioned without him. Or persons linked with Uber, companies linked with Elon Musk, locations linked with him, dates associated with SpaceX, or take a particular date and say, find me the most important person on that, people on those dates. Again, all this, we just take this, we can start off with a transcript, load it into the NLP API, take those entities, load them into the Inference API, and ask all sorts of interesting questions about the news media. Now, of course, that's all based on the textual captioning or ASR. But of course, television is a visual first narrative medium. So what about the video composition of it? What can we do with that? So we use Google's Cloud Video AI API. So again, we take the television news archive from the Internet Archive. We take those video files, we annotate them to the Video AI API. It's a turnkey API. We simply hand it a video file, and it hands back the annotations frame by frame of that. And we've been analyzing all kinds of different news here. Now, what can we do with this? Well, early in the pandemic, we asked it, we said, what are the visual things that you see in broadcasts more now during the pandemic than you saw before the pandemic? Number one thing that came out here was bookcases. Bookcases were everywhere, which you didn't see many of before, because again, before most guests came into the studio to be filmed. So that was kind of a shortcut. It told us that there was kind of the shortcut that here in the pandemic, everyone's filming from home, so they find any pile of books in their house, and that's what they film in front of. So it was sort of a shortcut for scholarly knowledge. But you'll notice here, we can see all this text here. We can see in the bottom of each of these frames, we can see text. So that's also known as the chyron, or the lower third. It's essentially a textual summary of what's on screen at the given moment. So it's maybe the name of the person being interviewed and their affiliation, or simply a description of what's being talked about at the moment. So the Video API actually performs OCR in, I believe, almost as much as 300 languages now. And remember, this is video OCR. So here's a good example up here in the upper left here. We can see this looks like gibberish. That's because the text was scrolling in at this moment. Again, it's able to look past that, correctly transcribe this. Worst case scenario here of, these are worst case scenarios for OCR, just flawlessly pick these up. Here's an interesting example. You don't have to tell it the language. It recognizes 300 plus languages on its own. You simply hand it a broadcast and it scans through and finds all the OCR in there. So here's an example of Chinese that was appearing in broadcast. Again, and a lot of these are, some of these are vertical, some of these are street signs at angles. Again, flawlessly transcribes all of that. Here's an Umar Media broadcast. This is actually Urdu language material that appeared on an ABC News broadcast. Again, flawlessly transcribed this, even though we weren't expecting to see that there. So again, you can just hand it a video file and get back all this on-screen text transcribed without even having to worry about, well, what languages. You don't have to sit down and say, what are the languages that I'm expecting to see here? It just does all that. So what can we do with this? Well, we can say, for example, how does social media drive television news? So we can say, take Donald Trump's Twitter account. How often does that appear somewhere in the on-screen text? And so we can simply hand in that Twitter account, instantly see all the cases there and plot out the seconds per day it appears. We can look at all the different, other words that are appearing with it and so on. So again, going from basically making the on-screen text searchable. Now that also allows us to do really interesting things. So during the pandemic, CNN has had this COVID-19 dashboard tracking various statistics. So that's a visual dashboard. So how do we track that? Well, it has a credit line, Johns Hopkins University. So we can simply search the on-screen text for that credit line and track the ebbs and flows of that dashboard over time by hour. And so we can do these really interesting analyses using text as a metaphor for visual pieces. Now, fact checkers oftentimes are interested in questions like, who's telling the COVID-19 story? Who are the doctors being interviewed on television news? So again, in that chiron, that text in that lower third, typically it tells us who's being interviewed. So we can simply use a simple regular expression. We can go in BigQuery, we can use a regular expression and say, find me all the DR period, so doctor, and then find the name that appeared after it, make a chronology over time, so we can tell who's telling that story. We can do things like visual similarity, so we can use the entities that are appearing on screen and look at how the television channels are the same or different over time. But here's a really neat application. So oftentimes in the news, you'll see a clip that just says, so here's a good example. This was a CNN broadcast during COVID. It just said in Russia somewhere. No information about where this clip was depicting, where it came from or anything else. So this is a really interesting application. We can connect video to the online world using the Vision API. So just as Google has the video API, does video, it also has something called the Vision API that does still imagery. So here we can go through and we can say, so here's this clip. We simply took a still frame. So we just took a screenshot of one frame of it and we ran it through the Vision API. Now, Vision API has something called web entities. It's essentially a reverse image search. You hand it an image, it searches the open web and gives you back a list of all the different image URLs that it found that image on across the open web. So we start with that. So again, we start off with this screenshot of this clip. We ask the Vision API to find all the copies it's seen across the web. And then we basically crawl each of those URLs and get the captions of the images. So now we've gone from this unknown clip to a pretty detailed description, but we can go a step further. We go into the metadata on each of those pages. So again, we start off with a clip on CNN. We take a screenshot. We hand that to the Vision API. It does an open web search, a reverse image search for that image, comes back with all the pages it found that image on. We then take those pages, we scan them. And here we're looking at for example, the JSON LD metadata on the page. And here we have this rich paragraph description of this video. So again, automated provenance. Now we can do this completely automated. So here is a complete broadcast once per second. So basically every second we take a screenshot of it. We repeat that same process. We also then, all those copies it found on the web, we scan for EXIF metadata. And so here we go. Here's a clip of someone looking in a microscope, and we can see this is actually a Getty Images, a stock image here. Here's another image of a teacher in a classroom. What is this? Where is this? Again, this frame, again, completely automatically. You start with a broadcast, drops it in the frames. We hand each of those to Cloud Vision. And here's one of the copies it found on the web. EXIF metadata gives us a complete description of what it was depicting. So again, autonomous provenance connecting television news to the online world. Now, finally, I'm going to leave you with this. So this is a new tool from GCP called the Time Series Insights API. It takes a time series data set and looks for anomalies. So we're actually, in the next few weeks, we're actually going to start running this over closed captioning and OCR text over television news to detect the subtle glimmers of emerging stories. So in other words, by analyzing the closed captioning every day and by analyzing all the on-screen text, we can look for words and phrases that are starting to appear more today than they have in the past. Now, here's an example. So this is applied, so to give you an idea of how powerful this is online news coverage on December 30th, 2019, looking for discussions of pneumonia associated with a given location around the world. So you can see, this is actually the graph for Wuhan. So we can see nothing, 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 boom. We can see all of a sudden this surge here. So this was detected by the API. So at the time period, again, what was described as the time period is SARS-like viral pneumonia of unknown origin in the Chinese language press. We can see immediately here. So we can see right here at 10 p.m. Eastern time on December 30th, 2019, the API was able to detect from our data that there was this new outbreak being discussed. So in the news media. So again, imagine that applying every day to television news where you can see sort of the earliest glimmers of those stories there. So again, that gives you the power of the cloud to analyze television news at scale. So using automatic speech recognition to generate autonomous captioning of television news, it's on par with humans. Whether we use the speech recognition or whether it comes with captioning in the first place, we can compute embeddings on it using TensorFlow to perform semantic search or visually cluster it. We can use the GCP NLP API to extract out the entities and analyze them using the inference or time series APIs. We can use the video API to look into the video content of the broadcast, OCR, the on-screen text. We can then use the Vision API to connect television and online news, searching the web frame by frame to connect back a television broadcast, to use sort of the web at large to understand it and enrich it, to annotate that broadcast. So again, using all these different modalities, all these different tools to understand television news in different ways. Now, everything I've shown you is open data. You can explore it today. So hopefully this inspires you to think about the powerful new lenses through which you can understand video using the power of the cloud. Thank you so much for joining me.